Welcome everyone to a new webinar on KAPE and F-Response. Today's session will walk through how to use KAPE and F-Response tools and how together they can be used to triage data remotely in a DFIR investigation. Today, we'll hear from Eric Zimmerman, a Senior Vice President in Kroll's Cyber Risk Practice. Eric is a former FBI agent who specialized in computer intrusions and other related crimes and is also the founder of KAPE. We'll also hear from Matt Shannon, Managing Principal and founder of F-Response, who is an expert in information security and computer forensics. Before we switch to Matt and Eric, a few housekeeping items. Today's session will be recorded and you will have access to the recording in a couple of days. We encourage you to submit questions via the GoToWebinar client, which should be floating somewhere on your screen. We'll try to answer as many questions as possible and follow up with answers after the event if we do not get to yours. A brief reminder that KAPE is free for law enforcement, government agencies, for research, academic, or personal use. If you're using KAPE in a paid engagement or on a third-party network, an enterprise license is required. Licenses are available at kroll.com/KAPE. If you're interested in learning more about KAPE and securing your certification, we have a few upcoming virtual sessions. These are small group sessions with ready access to Kroll experts, and we'll show this slide again at the end of the presentation for more information. And with that, I will pass it over to Eric and Matt.
All right, let me take over presenter here and then get the appropriate screen shared, which should be visible now. Now, we got a lot of moving parts here, and because of the time restraint, we're going to be moving relatively quickly. And so you've probably heard of the phrase drinking from the fire hose, and this will certainly be one of those instances. So we encourage you to ask questions either using the GoToWebinar questions feature, or you could throw it in the chat, whatever. And then when we get to the Q&A section at the end, after we're done with the presentation, we'll get to as many of those as we can. Now, on the screen here, you can see here, I've got a few different windows open. Here is where KAPE lives, and I'll just briefly kind of go through what's in there. And then up here, we've got an E01 mounted. And so this just basically is arsenal image mounter that is mounted in E01. And you can see here, we've got the F drive. We'll come back to that. That'll be a little bit more meaningful here in a second. And then one other thing to note, we have 4 volume shadow copies available in that image. But let's talk about KAPE itself. Now, KAPE is a command line tool, and that's almost always how you're going to use it if you're doing things at scale. But I'm going to show you the graphical version, which makes it a little bit easier to see the pieces and everything else. Now, before I start that up, I just want to talk a little bit about what makes KAPE do what it does. And so KAPE is really built around 2 principles. One, collect data, and those are called targets. The targets are what facilitate doing that. And then the other one is running programs, and those are modules. Now, in that case, we have to have configuration files, and if I go into the targets, we'll start there. Notice we have them grouped down by different types. Now, ideally, you want to keep your targets specific and granular and focused, and what that means is don't put 52 different types of files in a single target, because that way, if you want to only collect 2 of the 52 things later, well, you only have 1 target. So the way that we recommend that you do this, and the way that we've built almost all of the targets, is to have them very specific. So just as a brief list here, you can see prefetch and registry hives and so on. If I just select registry hives and prefetch, for example, and then we take a look at what these actually look like, you can see it's very straightforward on how these things work. We have a description, who wrote it, version numbers, etc. Now, this ID is basically just a unique identifier that is going to make sure that KAPE only runs a given target or module once. It wouldn't make sense if you reference the MFT file to collect the MFT 5 times. So as KAPE is running, it will only collect that particular target once. That's what the ID is for. So that's just a GUID. It just has to be unique and random, and KAPE can actually generate random GUIDs for you. It's one of the command line arguments. Now, below that, you can see we have 2 collections, 2 lists, if you will. First one, Windows prefetch, right? That's where they live. See Windows prefetch. And then we want everything that looks like star.pf. Now we have a secondary one, Windows.old, so that would be Windows 10 upgrades and Windows 10 to 11 and things like that. You're going to be able to shift back into that older Windows directory and grab those things and so on. So notice this also says C, right here, the path. We typically in targets always reference the C drive, regardless of whether or not we're going to target another drive letter later, right? You saw earlier I mentioned the E drive. Later we'll see F-Response and a remote mapped drive might be the F drive. KAPE will take care of fixing all of those things for you. We reference C because that's almost always where these things are going to be found. So just a little bit to go there. Now you can also do wildcard or wildcards, simplistic wildcards like this, or as complicated of a regular expression as you want in the file mask. And all of these, the documentation for everything is available online. If you just Google KAPE docs, it should be the first link for you. Now on the Registry Hive side, same idea, right? Except here, we've got a lot more individual little collections that we're going to be going after. There's the SAM Hive, there's the transaction files, all of these different things, the registry hives themselves. So it's really very straightforward how you define what you want. Name of the file, where it lives. Now, yes, you can traverse the entire volume if you want, searching for star.jpg or star.docx. That's also fully supported. There's plenty of examples in there on that as well. And we also have, last thing I'll show you in here is the ability to have templates, or the guides rather. So you can see there's a guide and a template. If you read through those, it will explain everything that you ever could want to know about targets and modules, but we have literally hundreds of these things that we already have available. Now on the module side, this is basically going to run programs. So if we keep into the same style of thing that we saw before and we go with prefetch, my piece of software that will parse prefetch files is PECMD. And so here you can see it looks very similar to what we saw on the target side. We've got a category, we've got who did it, we've got the ID, where to get the software. But down here, we have the actual command lines that are going to be used when we want to tell KAPE, hey, run PECMD against some prefetch files. So I don't have to type out any of those things. You can see here we've got references to % source directory %. That is a variable that KAPE will dereference at runtime based on the command line arguments that you give it, and so on. And again, we have hundreds of examples. We've got templates and guides and everything else for your reference if you want to build your own. But with that out of the way, let's go in here and actually run this thing and see what it can do for us. Now I'm going to just start up the graphical interface here, which really helps when you're first getting used to it to understand the various command line switches. Now, KAPE doesn't really care where it collects stuff from. So notice here we've got a target option, module option. I'm just going to turn on targets and notice this whole pane unlocked. Anything in red is required. Now, as I'm interacting with the software, notice how my command line is going to be affected as I type. So in my first example, I'm going to do a live response style collection. So I'm going to collect from the C drive. And then notice right there, it put the appropriate switch in place for me. If I hover over that tooltip there, we get a tooltip and it will tell you what the appropriate command line switch. Target destination, we're going to write that out to temptout. Notice it put that in there for me. Now here, I'm going to collect prefetch, because we talked about that a minute ago, and then we'll keep it simple. We'll just do some link files and jump lists. That's fine. Now notice what we have here. There's our full command line. We know it's valid because over here, the execute button is now clickable. Until you meet the minimum requirements, it is not going to allow you to execute that because you just would get an error. KAPE would complain, hey, I don't know what that is. You didn't give me all my arguments. Now with this in place, let's go ahead and do a collection. So it spawns KAPE, it's running, the search is over. In 0.1 seconds, it found 327 files, deduplicated 3, and copied them all into our target directory there. So it took 2.2 seconds to do all of that work. Let's go out of there, and there you can see there'stout. We collected it from the C drive, Windows, prefetch. There's all my prefetch files. And as you can see here, we've got users. There's all my link files that we collected. There's the 2 on the desktop that I made earlier, okay? So it basically collects everything, and you get a full audit trail of every single thing that went across the screen, as well as CSVs that will act as, and I'm just going to open this in Edit Pad. Usually you'd use like Timeline Explorer, but you get the source file, destination file, SHA, all the full 64-bit resolution timestamps, which have been reapplied to the files it copied, and so on. Now, that's a live response. We could do exactly the same thing, but against, right? Remember up here, we have this mounted E01. Now, in this case, it's the F drive. So all I have to do is change C to F, and I can repeat the exact same thing. Now, in this case, you might say, well, I want to process not just the active file system, but I want volume shadow copies. It's literally as simple as adding the VSS switch like that. Now, when I run this, several things are going to happen. Notice it's giving me a warning. Hey, there are files in your T destination, your target destination folder. I'm going to delete them before I copy new files. Why? So that you don't cross the streams. It would be bad if you put the same files or the same stuff from two different cases in a given folder. So it's warning you, and that's going to delete everything in that folder. So we hit OK. Now this is going to look very similar, but notice it found 4 volume shadow copies. And in 1.8 seconds, it traversed the active file system and all the volume shadow copies and deduplicated 555 files out of there. Otherwise, it's the exact same thing that we saw. There's the active drive that we searched. There's my shadow copies, full audit trail, and everything else. Now, the last thing I want to show you here briefly is modules. Now, in our case, we did link files and jump lists and prefetch. So I'm going to cheat, and I'm just going to run Easy Parser, which, if I double click this, you can see is a compound module that just runs all of my software. So there's JLECMD, LECMD, PECMD. That's what we care about. Now, when I run this, I have to supply another piece of information. Where do I want my stuff to go? So in that case, I want all of my analytical work to end up in mout. So from here, I click execute. We clear the directories. This is going to look exactly the same. But watch what happens when the copy is done, which is right now. It's running all of the command line tools against the data that it just collected. Now, in some cases, there aren't any matches, but it ran LECMD, JLECMD, and PECMD. In all of that, collection, dedupe, everything took 10 seconds, 10.6. So now here in mout, notice that we have categories, file and folder access. Oh, look at that. There's our jump list and link file stuff. We have program execution. There's our PECMD output. So within 10 seconds, and that's an image from a SANS class. That's a typical image. You could literally have your work product, your analytical work product, ready to go in about 10 to 90 seconds, depending on what you want. Now, I'm going to hand over control here to Matt in a minute. He's going to start talking about F-Response. And then after he's done, we're going to resume back, and then I'm going to show you some more stuff with KAPE using F-Response, that piece that Matt will be unpacking here in 2 seconds. So give me 1 minute to transfer presenter. Matt, you should have the con. Take it away when you're ready.
Yep. Thank you, sir. I appreciate it. Give me just a second and I will get that screen visible. All right. We should be able to see the F-Response screen now. Thanks a lot, Eric, for covering KAPE. It's a very impressive tool. I've known Eric for a while now, and I've been keeping track of KAPE and kind of watching it evolve and develop, and nothing short of amazing. So my name is Matt Shannon. I'm going to talk today about F-Response. Really what F-Response is and does is it's a tool and mechanism designed to give you access to remote machines, disks, volumes, and if the remote machine is Windows, memory, and to do that in a tool or vendor neutral manner over the network. As F-Response evolved over time, we added the ability to collect data, not only to create images of remote data sources like we talked about, those disks and volumes and memory, but also things like agentless connections, so the ability to copy file and folder content out of XMV and SFTP shares, as well as to create snapshots of cloud servers, things hosted on, say, Amazon EC2 or Azure Compute, as well as to collect file and folder content from cloud files, what we would think of when we think of things like Amazon S3, Azure Blob Storage, etc. So today what I'm going to do briefly is I'm just going to walk through sort of that standard F-Response process. What you're looking at on my screen right now is the F-Response management console. It's cut into 3 sections from left to right across your radio dial as data sources, items, and activity with messages along the bottom. Data sources are just that. They're sources of F-Response presentable data. Items would be instances of a given data source, activity being rather self-explanatory to things we're currently doing. And the messages tab will be a textual representation of the steps I take as I take them. So if you can imagine you're in a situation or an environment where you need to get F-Response running on a remote machine such that you can access the disks or the volumes of that machine live and then turn around and load them into a tool like KAPE, the first thing you want to do is get F-Response deployed to a remote machine. You can either deploy to that machine using our software to push the subject over the network. You can export a Microsoft software installer and import run the MSI on a remote machine. You can export a subject executable that can run on the remote system, etc. You got a lot of different ways to get the product on a remote machine. As far as the demonstration is concerned, we find that deploying it to the remote system makes it the most interesting demonstration. Prior to the start of this call, I went ahead and put in some credentials on my test network. If I were looking to deploy to a non-Windows system, I could put in a user account and assume root privileges using SU or CDEL, or a root account directly. All deployment to non-Windows systems is done with SSH and SFTP. Deployment to Windows systems is done with File and Network Printer Sharing Services, or SNB. I'm going to go ahead and put in the host name of a remote machine on our test network and press install and start. So what this is going to do is it's going to authenticate to that remote machine. It's going to copy an executable, register that executable as a service, and start the service. You'll see it took me longer to say that than it took for it to actually happen. What we end up with now in our management console display is a single machine, Windows machine, talking to our license manager and a visible. And at this point, we can do a couple of different things with it. We can attach a subject target. We could kick off an image directly. Attaching a subject target is just like it sounds. We get a list of potential target devices, physical memory, volumes, and disks. I can select a device and attach it to our machine as a physical drive. What we'll get is a new activity. That activity represents a separate process that spins up and maps disk 0 to physical drive 1. And here you can see Windows running out and assigning volume letters to the NTFS volumes it found. So to cover it at a high level, essentially what you've done is you've taken disk 0 of this remote 2012 server and attached it to your machine as physical drive 1 completely read-only. So at this point, you could create an image of it. You could use a spectacularly capable tool like KAPE to process data on that attached disk. Really anything you could do with a physical device that you had removed from a machine and plugged into your system with a hardware byte blocker, except you didn't actually do any of those things. So this gives you sort of a high-level overview of the base capabilities of F-Response. You can deploy and start software in a remote system, map a physical device. Like I said, we could right-click and image a subject target by filling out the imaging information, selecting a specific target. Our images would be created with E01, so expert witness style images. However, you could use your own imaging tool once you've attached the physical device. Like I said before, we do give you the ability to collect data from what we call agentless connections, so things like SMB and SFTP shares. We let you talk to Amazon EC2 as well as Azure Compute, and in both of those instances, you can pull down snapshots of existing volumes on running instances, whether instances are online or offline. You can create those snapshots using the internal API. And then lastly, Cloud Files will give you the ability to collect file and folder content from remote cloud storage environments, things like Amazon and Azure and Box and Dropbox and G Suite, which is now Google Workspaces, etc. So what I'm going to do is I'm going to hand it back to Eric. He's going to have a device map, and he's going to show you what it looks like when you take an F-Response device and you pump it into something like KAPE. I see there are some questions here on the webinar, and we'll definitely get to those at the end of the call. All right, Eric, it's all yours.
Let me get control back here and then share my screen out. Should have it now. Now, there have been some questions that have been rolling in, and I have been answering them as best I can. Matt, there are some F-Response specific ones there that I'll let you take a look at and answer in the question section, or we can just wait until the end, either way. Now, also, as Matt had said, I have taken over a different set of data, but I've basically used F-Response in my environment to access a remote disk, which you can see here is now a physical drive on my system, and it's showing up as drive letter E. Now, as far as Windows concerned, that thing is attached, and it's going to behave exactly like it's attached, and it's going to emulate a physical disk, which is absolutely critical when it comes time to start interacting with volume shadow copies. If your data mounting tools do not emulate a physical disk, you will not be able to target volume shadow copies, and those are a huge source of very relevant information. So to kind of kick this back off and continue where we were, let's just go in here, but instead of the F drive, I'm targeting the F-Response mounted volume now, which was E. Now, for this point, it's going to look exactly the same, right? We could do shadow copies and all that. I'm going to, though, add a couple more options to give you some more flavor for what KAPE can do. And we're going to shove all of the data that we collect over, in my case, a local area network. It just as well could have been the internet or anything else. As long as those ports are routable, you're good. So base name, this is the name of the container. We'll just call it KAPE demo, whatever. And then we hit go. Now, this is going to look exactly the same. It found 2 shadow copies on that remote system, but notice here there's over 2,000 files that it found. It is going through and pulling all of those files, essentially like it was a locally connected drive, because for all practical purposes it is, and it did its work, and in 15 seconds, we now have a zip file. If I extract out the zip file of VHDX, that is everything that I collected. If I right click and mount or just double click it, notice that I get a new drive letter that shows up. There it is. So there's my KAPE collection. You can see here, it gives me the date of the collection and everything else. There's your files. Go in there and do your thing. And when you're done, you can simply unmount this, eject, and you're off and running. Now, you should take steps to always make sure that you have a copy of that original evidence, right? This file right there is your original evidence. Extract out a working copy of the VHDX and never get rid of that zip file, because if anything ever changes, breaks, revalidate, whatever, that is your source of original evidence. Now, I love the fact that you can very quickly collect all of the artifacts from any system that you want, mounted E01, remote disk with F-Response, system in the cloud, whatever, and you can preserve the actual artifacts themselves and then generate your work product. It becomes very difficult long-term to defend what you did if you don't have the original artifacts to then run a secondary tool to validate your findings, regenerate and validate what the output was. In other words, if you just do live response data and say, dump all of the prefetch data to a CSV, well, what if somebody later wants to look at the source evidence that you used to generate that CSV and you didn't collect all of the prefetch files? You're going to have a problem. So by using KAPE to collect those files, we have now preserved those files for forever, for posterity. Burn it to disk, back it up somewhere, and you now have a copy of everything that you did. Generate your work product as much as you want off of the stuff that's in the VHDX. Now, another option, which I'm not going to demo here, but that you can do, is the transfer option. So if I turn on transfer here, notice that these transfer tab opens up. You can shove out targets that you've collected, modules that you've run out to an SFTP server, and KAPE has a built-in SFTP server that you could stand up in a temporary fashion, do your work, and then shut down that secondary instance of KAPE. That way you don't have some Linux FTP server floating around out there you got to worry about. Stand up KAPE, SFTP, do your thing, and it even specifies all the usernames and URLs and switches and everything else that you might want. You can shove things out to S3, AWS pre-signed URLs, or Azure storage, and it will just, it doesn't care. It's going to shove those either zip file or VHDX out over the wire. Now, one of the other interesting things that you can do, especially when it comes time to start looking at the output and verifying in the spirit of trust but verify, well, there's other options down here, debug and trace. Now, trace that is going to be like drinking from the fire hose. And I would only do that if you're really trying to get down in the weeds as far as what KAPE is doing. But debug can be very useful for when you're making your own targets and modules and you want to make sure that the syntax is right, that it's finding the files that you're expecting it to find, and that your command line tools are actually running as you would expect. Now, I'm going to do the same collection here, except we're going to leave debug. We're going to turn debug on and watch what happens. Same beginning. Hey, I'm going to delete the contents here. We're going to run this. Now, notice how much more data is shown on the screen. So this will take longer, and it's taking longer because of all the stuff that's getting blasted out to standard out. All of the stuff that's going down past that screen really, really, really fast is going to be in our log file for the console history as well. So there's no, man, I couldn't scroll back, or it was just running too quickly. Everything is going to be preserved there. Now, why would you want to do this? I want to see all of that stuff that's going on. Now, look at what it's doing here. That's the actual command line output that you would see if you ran each of those command line tools manually. And so, in other words, when you have debug turned on, whatever those command line tools are dumping out to standard out is going to be captured. So in here, if I go into my output now, notice how much bigger it is. So if I keep scrolling down here, this is the executions down here of all of, in this case, this is PECMD, but look at how much stuff it's showing you. This is exactly what it would look like if you ran that command manually. So it is going to give you, when you have debug turned on, all of that additional detail that would have went by if you would have run these things by hand. That helps you if you got a command line switch wrong, right? You're building your own. You want to have an understanding of what it's actually doing under the hood. Debug is going to be really useful. I won't do trace only because it's really going to hammer. It takes a lot longer because there's even more detail. Now, earlier I had showed you here, we have this notion of a compound target, or this is a compound module. So notice this module, because it references other things that end in MKAPE, MKAPE is a module extension, it's going to simply run all of those individual modules. So this is how you can take 50 different individual artifacts, $boot, $MFT, USN journal, link files, browser history, and you can turn it into a single thing that you want to collect. So notice here, this is, for example, the SANS triage target, that we can reference all of these various targets in here so that you don't have to sit there and have 52 different targets on the command line. You literally can run the name of your compound target, and it will go through and say, oh, I'm going to get you antivirus, cloud storage, combined logs, evidence of execution, and so on. So this is how you can be extremely flexible with collecting a little or a lot, depending on your needs. Now, like every other tool out there, this is a tool that you have to understand the pros and the cons and everything else. There's a balance here, right? Triage, by definition, is not going to be equivalent of a full disk image, right? Doesn't make it just doesn't make sense to say triage is equal to an E01. It's a balance. Now, in a typical case, the normal amount of data that you're going to look at is roughly 1 to 2%. I don't care how good of an examiner you are, how thorough of an exam you're going to do, you're looking at about 1 to 2% of the data to answer the questions involved on that particular computer. So why spend the time to collect 98, 99% of the files you're just going to ignore, right? That's the entire point of triage. Now, I'm not saying that based on your triage collection, you're not going to have to go back to your data source and pull additional files. Maybe you need PDFs, maybe you need CAD drawings or Word documents, depending on what the triage data told you. But that is a very different scalability problem, right? It's a solved problem. When you saw how fast it is, 10 seconds, I can give you the data that you want to answer questions versus 4 hours per machine simply to image, not even verify, not even analyze. So there is a trade-off there, but triage is really the way you have to go in order to be able to do this quickly at scale. If you're only dealing with one computer, who cares? If time doesn't matter, Time doesn't matter. Who cares how long it takes? But if I have 10, 20, 30, 40, 1,000 machines to go through and pull, I'm not doing E01s. I'm using KAPE to target that data, to pull it down, and then start my analytical process literally in minutes. I can have a bunch of machines done using KAPE, targets and modules, let's call it 30 seconds to 5 minutes, to give me everything and more that you would ever want to analyze. That is going to give me a significant amount of capability to project into an environment and gather a ton of critical information very, very quickly and preserve it in a forensically sound manner. Now we're coming up here on the end of our demo-y type thing, and so if you have any questions, what we're going to do here, I'm going to turn this back over, and then we're going to start looking at these questions. It looks like we've got most of them answered, but if you have any other questions, start firing them in, and we'll just start answering here in the last, I don't know, 9-8 minutes that we have. We'll go ahead and start taking a look at some of these questions. So let me return presenter here. All right, that should be returned. Take it away, and then we'll start looking at these questions here.
Thanks, everyone. Thanks, Matt and Eric. That was such a great demo. We're now entering the Q&A section, as Eric just mentioned. Also, we've addressed a bunch of questions that have already come in, but I think we have a few more. So Eric and Matt will start to go through those. And if you have anything that comes up, please feel free to put them in the chat.
So I see here, hi, Eric, can you briefly discuss the capabilities to upload to an FTP site? It's literally just some command line switches. Now, if you use KAPE to do it, there's a special configuration file, and there's an example on the KAPE Docs website. You define your usernames. You define the permissions. Do you want to have write only? Do you want to have read write? And so once you tell KAPE via a command line switch, execute its built-in SFTP server, it's going to launch an SFTP server in one instance of KAPE, show you all of the various IP addresses that it can listen on, and it gives you all the command line options to just paste into another instance of KAPE. When you do that, and then in another instance of KAPE, you use those command line switches, KAPE will collect all of the data and then upload to that SFTP site everything that it collected, targets or modules. The only requirement is you have to have them zipped, which you're going to be doing on almost every case. Let's see the next one here. Can you run KAPE on more than one computer at the same time? Sure. You can run it on 10,000 endpoints if you want. Fully capable with EDR systems. We have PowerShell one-liners that can deploy to as many machines as you want, run KAPE and do a whole bunch of stuff on the KAPE Docs website. So absolutely, you can run a ton of things in that regard. There's no like serial one at a time kind of things. You can do whatever you want. There's a couple F-Response questions. I'll defer that to Matt here in a second. Can KAPE RAM capture with magnet RAM capture be done against the remote memory of a system with F-Response? Sure. You could either run KAPE live on the endpoint to do that, or if you use F-Response to map memory, you would just target that. Well, I'd have to look into that. I don't know that that would be the best way to do it. F-Response is going to map the memory back as a physical disk. And so KAPE is not going to understand where to look because there's no drive letter. So you wouldn't want to use F-Response in that way, but you can run KAPE as a module on the endpoint to capture memory using magnet, RAM capture, or whatever else you want. If you wanted to image memory using F-Response, you'd have to point some type of a collection tool, DD or whatever, at that physical disk, and then it would dump down memory. Matt may have some more to add on that in a second. What are some key differences between the tooling when it's compared to some of its competitors? Not really sure there. You'd have to give me some specifics as far as what are you looking for or whatever. So all tools are going to have pros and cons. I can tell you one key thing that my tool that KAPE is not going to do. It's only going to run on Windows, and that's just a byproduct of where is the most opportunity to do these kinds of things. So it's not going to run on Linux. It's not going to run on a Mac. Now, if you had SMB or some other type of a share mapped, you could search KAPE with it fine, but there's obviously no volume shadow copies or some of the other more interesting forensic-y type things that you're going to be able to do there. What about compatibility with antivirus and firewall? Firewall is going to be a concern if you're using F-Response. You're going to have to make exceptions for those ports. KAPE, I've not heard anybody give me anything that says, oh, Norton said KAPE is questionable and it quarantined it. If I was doing this in an environment, I would probably would make exceptions to those just to be safe up front. Is there a target specifically for images? There are examples, and I assume by images you mean like JPEG, bitmap, PNG, whatever. There are examples in the disabled folder that will show you how to iterate an entire drive for every single possible picture, video, Word documents, etc. So we have those built as well. So pop-ups, no, that's more temporary internet files. I don't think you'd be having too much luck there. That could be quite a bit of work. Let's see, could KAPE target be written to include the SANS triage artifacts and then all user data file folders? You could. That obviously, yeah, that would work fine. You literally could make a target that says users app data star, and you'd get every single thing in the app data folder. I would probably lean that toward the way overkill as far as collection goes, but it absolutely could. Let's see. Does running KAPE on a live system affect the admissibility of the endpoint? No. Any triage tool that you do is obviously going to have an impact on the system that you're executing it on, right? You are changing, well, Windows is changing data. You're going to get new prefetch files. You're impacting things in memory. That is not going to be an issue for you if you document what you did and you justify why you did it, right? You are not altering any of the evidence that you're collecting, right? You are not going to be affecting a prefetch file that you're going to look at to say, oh, look, this malware ran, or this person used this peer-to-peer tool. I have run my software, be it KAPE or OS Triage, on literally hundreds of thousands of computers all over the world, and I've never had one issue where it's been inadmissible because, oh, you were on a system and it was run live. No, that's just not a concern anymore. In fact, it's never really been a concern, but that's kind of an old style of thinking as far as it relates to triage. I read online that KAPE can be run and deployed to off-network computers. Yeah, Matt would have to answer that one. Is there a tool that will let us ingest the KAPE output into a centralized console? If you mean by centralized console something like Splunk or Elasticsearch or Logarithm, you could simply write ingesters for all of the CSVs that KAPE will output. The SoftElk VM by Phil Hagen already has ingesters that will do a lot of that stuff for you. So yes, that's possible. Let's see, does the webinar, okay, that's not here. Do you have a recording of this? Yes, we have a recording of it. Can KAPE collect unallocated? No, collecting unallocated is not a function of triage. Could you run a module that dumps out unallocated, like something from SleuthKit? You could, but that's not a function of triage, right? Could you use F-Response to map a remote drive and then carve over the network? 100%. I did that all the time when I was an FBI agent. It worked great. We put people in jail for a long time in child exploitation cases, carving over the network for deleted data using F-Response. Fantastic tool. I've never had it fail on me. Can FTK image, scrolled, can FTK image file be used as a source? If you mean an 81, that's not really an image. You could mount that 81. I don't like the way FTK maps those types of files. It's not a real file system. It's kind of an emulated file system. So in other words, if you map using FTK Imager as a it's kind of emulated file system, pointing KAPE at that is not going to behave as well as you'd want. If you do it as the read-only, it's going to treat it much more appropriately. But if it's an 81, yeah, you could, but it's not going to work as well as if you had an E01 or something like that. Is triage accepted in courts? Absolutely. I can't tell you like I said, hundreds and hundreds and hundreds of cases that I've been on where we have used triage, and it's completely admissible. I've never even been subpoenaed to testify as to the triage tools. They just work, right? You can run them 100 times and you're going to get the same results, all that kind of good stuff as well. I am not aware of any antivirus that's blocking KAPE. I'm not aware of it. That doesn't mean it may not exist. Can KAPE pull artifacts back into a KAPE managed system? I suppose it could, but you're going to have to do some automating once KAPE pulls the data back into like a staging area or something like that. KAPE wouldn't do it, but you can certainly subsequently automate pulling things in there. Let's see. Not really sure on that event ID one. Oops, it scrolled again. For web browser history, will it collect the data that's been removed from browser history? No, right? This isn't something that can, find things that don't exist anymore. If your tool had the ability to go find that, like from a SQLite database, KAPE can pull the SQLite database. Now, if you have a forensic tool that can then process SQLite, looking for deleted fields and tables and stuff that's in there, sure, you'd get it. But otherwise, no, you wouldn't get it from there. That would be a function of the module more so than KAPE. That would be 100% dependent on what module you're running for browser history. Now we're coming up on the end of our time here, I think. So if any other questions kind of trickle in here, we can take a look at it. But otherwise, I think we're pretty much ready to wrap up here. So I'll stop talking and hand it back to you.
Thanks, Eric. I think a couple more questions have come in, so we'll make sure to follow up with those who asked after the webinar. Thank you both again for your time. And as I mentioned earlier, if you'd like to learn more about KAPE, we do have a number of upcoming training sessions where you can hear more from Eric, our expert. That is unfortunately all the time that we have for today. Again, thank you, Eric and Matt, for an awesome, informative presentation, and thank you all for attending. Have a good day.
We'll stick around here for maybe 5 more minutes and answer the rest of the questions. So maybe if you give us another 5 minutes, Hannah, then kind of just say, okay, we're going to shut it down. We'll just get these last ones addressed.
Yep, go ahead.
Okay.
All right, so one of these questions here was the F-Response demo. Was that a new version that allowed to emulating the disk over the network? So pretty much all versions of F-Response, with the exception of the newest version, F-Response Collect, emulate disks over the network. That's what we've always done. That's how you can leverage tools like KAPE. A lot of my answers during the webinar when people were asking me about systems that were off network or in a zero trust environment, that is a task for the new F-Response Collect product, which is designed for what we would say unstable internet, zero trust sort of environments. But for the other versions of F-Response, Enterprise, Universal, Tactical, Consultant, all of those versions do allow you to map the remote disk as a physical device, such as you can load it into a tool like KAPE. All right, I think that's about it as far as any residual questions for me.
Yeah, there's a bunch of questions on is this going to be recorded? Are we going to get it available? Yes, it will be available. This was recorded, so you can go back, get it, whatever. There's probably 6 questions in there. Let's see, for the available KAPE courses, are they purely related to acquisition? Both. The KAPE training is 2 parts. The first half of the day is easy tools. So MFTs, shell bags, registry, there's like 6 different tools. Then once you know about all those tools and the artifacts, the second half of the day is KAPE, how to use KAPE, how to build targets, how to run modules, so that you see what KAPE is going to be automating for you, right? That's why we start with manual easy tools at first, and then you automate everything. Learn how to do it manually, then you automate, right? I don't want to teach you automation, and then you have no idea what's going on under the hood, because then you're like, what happened? I don't know, I just ran the tool. So there's a very specific way. The courses are not free for KAPE. There's a very specific way that we go about the training to equip you to be able to testify, justify your decisions, be able to explain what you did, and all those types of things. Okay, so looks like that's about it. So whenever you are ready, we'll hand it back and shut this thing down. Thanks again to everybody for attending. And if you do have questions, please, you can always email kape@kroll.com. I'm easy enough to find. You can reach out to me directly. Andrew Rathbun is also a subject matter expert on this, and so you can find him on Discord, and we're always happy to dive into a bunch of other things for you. So with that, I think we're pushing it now, so we'll go ahead and shut this down. Thank you everybody for attending, and look forward to seeing you in the future. Take care.
Yep. Thank you all.
Thank you.